Part 1, Question 1. Pick from the list of graphs below which graphs you can use to describe categorical data. So when we're talking about categorical and numerical, the categorical graphs are those that can show a portion of a whole. We'll be doing a lot of examples of flipping coins and M&M, the color of M&Ms in the bag. And you want to think of how much of the piece of the whole does something make up. And so the graphs that best represent that are pie charts and bar charts. The pie charts showing that we have one part of a whole, as well as the bar graphs do the same. Question 2. When given a sample, what is the formula to compute p hat? Explain what each variable stands for in your formula. Okay, so our formula is as follows. So we have for our p hat, p hat is equal to x over n. And the x, or the n, excuse me, let's start with the n. The n represents all pieces. And then the x represents what you're looking for. Okay, so a few quick examples to help understand exactly what that's talking about. We could have, in the M&M example, we could have a total in one bag of, let's say, 35 M&Ms. Now, if we are looking for how many blue M&Ms there are in the package, and we count and find that there are 7, then our p hat would equal 7 over 35, or 1/5 would be our p hat for that. If we were looking for how many blues and yellows, and say we had 11, then there would be 11 over 35 would be our p hat. So what you're looking for divided by the total amount that there are. Question number 3. What is the mean of the sampling distribution of the sample proportions p hat? Okay, so this is represented by the letter P. And that letter P stands for the population proportion, or the proportion of the whole. So in our M&M example, if in one bag we had 7 blue and 35 total, then our P would represent how many blues there are on average in all the bags that are made. So the p hat is for your sample, and the P is for the population proportion. Okay, question 4. What is the standard deviation of the sampling distribution of the sample proportions p hat? Okay, so the standard deviation of p hat looks like this. So I'm just going to put standard deviation of p hat. Okay, the equation for this is as follows. The square root of p times 1 minus p divided by n. Okay, now let's break these down into what they actually mean. So our n represents the total sample size. So however many samples that we took. If we did 10 bags of M&M, it would be 10. Our p represents the population proportion. So if the M&M company publishes the proportions of colors that are in their bags, then that's what would go here. Sample size, population proportion. And that would give us the standard deviation of our sample. Question 5. What is the difference between categorical and quantitative data? What are a couple of examples? Okay, so the categorical and quantitative data, there are a few major differences. In the categorical, we put things into groups, or we divide our samples into groups that have a specific characteristic. For example, we may divide them up by gender, or we may divide them up by eye color, or maybe favorite ice cream flavor, or which state they live in. Those are all categorical when you can group it by a characteristic. Numerical, on the other hand, are things that we can measure, and so height or age. And so one thing that you can do to try and decide which is you can think of, can I multiply this by 2? If I am 5'8", can I multiply that by 2? Well, yeah, that'd be huge, be really tall. But you can multiply, you can do math, arithmetic to it. That's numerical data. Categorical, on the other hand, I come from the state of Idaho. There's nothing really you can do mathematically with that. And so that's a few examples of the difference between categorical and numerical data. Question 6. Open the file class survey and create a pie chart for the class rank. Label it and post it here. Okay, so in order to create this pie chart, we're going to open up our class survey right up here at the top, this Excel document. And off to the side, we're going to make a little chart that will help us to make the pie graph. So we want to know how many sophomores there are out of the whole class, or how many juniors, what portion each of the different classes make up as compared to the whole. And so in order to do that, we are going to make a rank and count chart. So in order to do this, we can type in our 4 different classes, our 4 different ranks. So we can start with freshman, sophomore, junior, and senior. And then in the count section, there's a pretty handy command in Excel called COUNTIF. Okay, and what that is going to do is that's going to tell us count all the cells and then comma with this in them. So we're going to count all of the cells in the rank. So all of these cells right here. We wanted to search through all of these, and then we're going to put a comma and then what we're searching for, which in this case is freshman. And make sure to click on the box where you've typed it in. Hit count, and we have a total of 8 freshmen. Okay, and then if you double click on the box in the bottom right hand corner, it'll count up the rest as well. So one more time, that's COUNTIF from wherever you want to include. So we want to include the counts and rank, and then you click on whatever you want it to count, and then Excel knows to follow it along the side. So there's 8 freshmen, 75 sophomore, and so on. So in order to make the pie chart, we can just highlight what we want it to chart, come up here to the top to insert, and then over across to pie. And then you can select whichever type of pie chart you would like. Okay, and there is the, you can add data labels if you want so that it shows exactly how many there are in each category. And that is your basic pie chart. Question 7 asks, next create a bar graph for class rank. This is very similar to making the pie chart. You just select the material that you want to graph, come up to the top under insert, and then bar. And there will create your bar chart. Easy as that. Question 8, use at least 5 descriptors to describe the data above. Okay, so there's lots of options that we have here in this question. There's 2 main formats that you could write your descriptors. The first is represented by p hat, and then with sub-letters describe which p hat you're going to talk about. So let's start with the p hat of freshman. I'll write it like that. And that's equal to, if you remember, our general formula of p hat equals x over n, where x is what we're looking for, or the proportion that we're looking for, and n is the total. Okay, so here in our data, we had 8 freshmen. Of those 8 freshmen, so there are 8 freshmen, and we had a total of 183 students. And then you can just type that into your calculator to get your proportion of 0.0437. Okay? I'll do it for one more, and then it should be pretty simple to follow along. So remember, p hat of the sophomores this time, our total is still 183. There's still 183 students that we're talking about. And there happen to be 75 sophomores. And if we looked at what that was in a decimal form, you get 0.4056. Okay? Now, what these represent also is in decimal form is the percentage. And so they're 40% of the students that were surveyed were sophomore. 4% of the student were freshmen. And you do that by just moving the decimal 2 places to the right. Okay? Another way that you could do it is you could make a chart, what's called a frequency chart. And a frequency chart shows the same material, so we could have class count and proportion. Okay, so this is going to be doing the same calculations. So in our class of freshmen, we had 8, and when we found that proportion, again, taking our 8, dividing it by our total, we get the 0.0437. And you could go on and on for that. And so those are two different ways that you could describe some of the statistics from this data. Okay, so question 9, part A. What is the mean and standard deviation of the sampling distribution based on 750 users? So the mean is just the 7%, or the 0.07 that was given in the problem. That represents your P, or the percent or the proportion in the whole society. The standard deviation, we're going to use the formula that we learned in part 1 of today's lesson. Okay, so real quick review, P hat is equal to your population proportion, P, 1 minus P divided by N being your sample size. So see if you can come up with these numbers on your own. The P is the proportion of the population, or the mean that we just solved for. So the 0.07, 1 minus 0.07, all divided by our sample size, which in this case is 750, is what they told us. Okay, and then you can just plug that into your calculator. Just really make sure to include these parentheses. And in some calculators, you need to include parentheses right there as well. Okay? Part B, state the problem in terms of the variable p hat. Okay, so we have our proportion, or our probability, that p hat is greater than the 60 divided by 750. Okay, and what that represents is what is the probability that there are more than, so the greater than the 60 over 750, that it's greater than 60 people that don't use a home phone. Okay, so that's how you represent this problem. C, draw a picture, the normal curve, and shade the desired area. Okay, so we are looking for, we can have a normal curve here, and we want to know what is the probability that more than 60 have it. Okay, so it's just, we're not doing any specific calculations, but just some area out here to the right. So the reason that I shaded it kind of over here to the right is we know that the true mean is 0.07. And so right here, this is where we have the 0.07. And so we know that 0.08, or 8% of the population, in order to get that percentage, we're going to have to come out here, always. And then it's, of course, it's shaded anything to this side, because the numbers that go out farther this way represent even a higher proportion, 9%, 10%, 11% along the way. Okay. D, convert or standardize the values of p hat using the standard normal variable z. Okay, so the equation that we need to use for in this case is that z is equal to your value minus your mean divided by the standard deviation. And that's something that we've learned back in units and practiced through units 1 and 2. Okay, so our value, the value that we're looking at, or the percentage that we're interested in, is the 0.08, which, remember, we got that by taking 60 and dividing it by 750. And then minus our mean, which is our national average, which is 7%, and dividing that by the standard deviation, which is what we solved for in an earlier problem, which was 0.0093. Okay. As you plug that into your calculator, you'll come out with a z of 1.075. Part E, find the area under the standard normal curve. Okay, using the applet. So we're going to come over here to the computer and open up our normal probability applet. And remember, in this case, just like we drew in an earlier part, in part C of this question, we're going to be shading only the right-hand side. And then we have an area of 0.14, or excuse me, we have a z-score of 1.075. Hit enter, and we now know that our area is 0.1412. Question F. Interpret the area. So there is, the area represents the probability that the sample has more than 8% cell phone only households. So once we found the z-score, plugged it into the applet with the appropriate side shaded, that area represents that proportion, or it represents that probability of the problem that we had.